Hi, welcome to the layout tutorial. So I have a common source amplifier with me that I want to lay out. So to start with, we have to go to launch and layout Excel. Since we are creating a new layout, we have to select create new. If you are editing an existing layout, you have to go to open existing. Leave this as automatic and we'll just go to layout window. So this has to be, the name has to be same as the cell name that you are doing layout for. So clicking OK has opened the layout window for us. So how do we get started? So every time you open the layout window, your first step should be going to options and going to display. So you have to make sure that this snap spacing is 0.005. Even if you are opening an existing layout, you have to check this. So every time you open the layout, just fix this. This should be 0.005. Okay. Now, so we have few components in our layout, in our schematic window, and we want to take them to our window, layout window. So what we have to do is, there is an option of generate all from source at this bottom. So we'll click on generate all from source. We have to select what we need to generate. So here right now I'm generating instances and IO pins and a PR boundary, a boundary that will be around my circuit. So I'll click OK. So this is the PR boundary and these are my components. So this is the capacitor, MOSFET and a resistor, and here are my pins that were there in my schematic. So as you can see, these things are just looking like a black box to me now. So to enable their view in the deep layers, we have to press Shift F. So Shift F will reveal all the layers in those components. So this is a capacitor, a MOSFET and resistor. So let's start with properties of a MOSFET. So I'll just take this MOSFET up. So this is a MOSFET. So as you can see, this is a 20 micrometer wide MOSFET. So this is my source and drain, and this width is my, or this distance is the length of my transistor. So this is 2 micrometer set by me in the schematic, and the vertical distance here is the width. So this is the width, this is the length. So what I have to do is, I don't want to lay my transistor as, what do you call, is disproportionate as this. So we'll use our concept of fingers and multipliers. So we will go to the properties of this MOSFET. You can right click and go to properties, or you can just click Q. So we'll go to properties, we'll select the parameters. So as you can see, this gate width is 20, right? And there are no multipliers and fingers of this MOSFET available to us. What we have to do is, we have to go to our schematic window. We'll change this MOSFET to a MOSFET with 2 multipliers. So I will change this multiplier to 2 and I have to reduce the gate width since my multipliers are 2. So effectively, I again have a MOSFET of width 20 but with 2 multipliers. So I'll again go to my layout window and I'll update this. So right click, go to update and update from source. I think I forgot to save it. So to select it, right click, update from source. So it's not obeying my orders. So suppose I need to generate a single instance from my schematic. So what I will do is, there is one more option, generate selected from source. So I'll click on generate selected from source. I have to go to my schematic window, select which component I want to generate, and then I'll again go to my layout window, and these two MOSFETs are there. So these are two multipliers for the same MOSFET. Fine. Still, these MOSFETs multipliers are quite long. Now what will happen if I introduce a extra finger in both of them? So I'll again go to my schematic and I will increase the number of fingers to 2 fingers. So in SCL, increasing fingers doesn't increase the total width, so I don't have to do anything in the total width. I'll just apply and save the schematic. And let's see, trying to update these. So I'll select them and I'll go to update from source. So this time it worked. So they just merged somehow. So I'll separate them. So now you can see that these MOSFETs are more like a square. What we effectively want is, suppose at this top right end there is some difference or there is some gradient of diffusion of carriers, or suppose there is some etchant gradient, the concentration of etchant is not uh, uniform throughout. So what we want is the change from this end to this end should not be too much. If we use a very long MOSFET, the change across it will be very high. So we want it to be a very compact MOSFET for good matching properties. So as you can see, I have my source. So these notations are, this is the name of the terminal and this is the net it is connected to. So it shows the net in which it is connected in schematic. So this is my source, this is my drain, this is my source. Where is my gate? So this red line is basically a poly running between source and drain. This is my poly. Red color is my poly. So I need connections for poly. So what I'll do is I'll select them both. I'll press Q. You have to select both the instance here, and then you will show internally connected gate. So you will do it like, okay, we want bottom connections. So I am clicking bottom because there is already a source connection at the top of both of them. So I'll select bottom connection for both of them. So I have a gate connection. So this is the gate terminal connected to VIN in my schematic. Similarly for this MOSFET also. So both of them are identical. Now MOSFET also has the 4 terminal known as body. So the DRC rule is you have to have a body terminal known as tap, it at least in a distance of, at least one tap should be there in a distance of 30 micrometers. So to get a tap, you have to go to properties of the MOSFETs and you have to click in show tap properties. Yes. So you can select wherever you need the tap. So you need to select the direction. So suppose we need it in the right direction. And this is the percentage. Suppose I keep it at 50%, then the tap will be 50% of my total distance. If I keep it 100, it will be 100%. So I'll just click OK. So this is my MOSFET with 4 terminals. So what I'll just do is, suppose you want to, if I want to make a symmetric layout about this axis, suppose this is my axis, this line what I have drawn is my axis. If this is my axis and I want it to be symmetrical, what I have to do is I have to flip it. So to flip it, I have to go to this option. There is options of rotating, flipping. So I have to flip it horizontally. So this is my MOSFET. So these MOSFETs are now symmetrical around this axis. So I'll just delete my axis. It's not required anymore. So as you can see, this is a body terminal and my body terminal is not shown any contact from here. It is grounded, but it is not shown to me. So what happened is, these property that we changed in the MOSFETs, we changed it in the layout. Now we want to reflect those changes in the schematic. So what we will do is, we will go to right click, update. Earlier we did is, we updated it from source. Now we want to update the schematic parameters because we have already changed the layout parameters. So we will click on schematic parameters. So you can see that it has changed the right tab to yes and whatever changes that we have made. So now we will be getting our body contacts also in the schematic. So this MOSFET is perfectly as it is in the schematic. Next, Okay. So we did with flipping it. Okay. So now suppose these two MOSFETs, since they are multiplier of a same MOSFET, they need to be connected with every terminal. So how do I connect them? So to connect them, we have two options. So here is a palette. This palette has every metal, every layer basically that we will be using in our layout. So as you can see, this M1 stands for metal 1 drawing, metal 1 label. Similarly, metal 2 drawing, metal 2 label, and so on. So in SCL, there are four metals: metal 1, metal 2, metal 3, and metal top. So you can use four metals. So suppose I choose M1. One option is I can draw a rectangle. So I will choose metal 1 and I will go to create shape rectangle. So the shortcut is R. So this is a rectangle that I can draw. So if I want to connect this gate to this source, what I have to do is I have to go to this corner. So leaving hanging edges will give you a DRC. So you have to be very precise. You have to start from this corner and you have to draw. So can you see that there is a minimum area and off screen and minimum width? So these are DRC notifications. So there is an option above that I have enabled. It is DRD notify on. So this will tell me if I am doing something wrong with respect to the DRC rules. So again, I have to draw a rectangle and then I have to be very precise. The next option to draw metals or any other layer is a path. So we'll go to create shape path. So what path will do is it will give you a very clear line that you can control very well, and this is very good for routing. So earlier as you have seen, the rectangle was not very much controlled. This is very controlled. So double clicking will end up the drawing. So this is a path. So one more good advantage of path is I will click P to get into path. Suppose I want to connect this metal to something. So as soon as I get there, this will automatically snap to it. And when I click and start, it will start from that metal and done. Even I don't need to select my metal. Even if I am in metal 2 drawing and I go to path to metal 1, it will start with metal 1 and it will automatically switch to the metal that I am drawing. Fine. So this is how we will connect the metals. Now, okay. So we are done with the MOSFET. So let's arrange the things as we want. So I have a layout ready for me. This is how I want it. Okay, let's see what happens. So this is my resistor. This resistor, the plus terminal is connected to VDD and the minus terminal is connected to Vout. So these are the two contacts that we have discussed in class. So these contacts will also result in some contact resistances. That is why we want unit design for resistances also. So suppose this is connected to VDD. This is the only terminal connected to VDD. Suppose I keep my VDD here. So this will be connected to VDD. Now, as you can see, these two are at metal 1, correct? This is at metal 1, this is at metal 1, and these two needs to be connected. But since there is a metal 1, I don't have permission to cross over from here to here. So here what I can do is I can create a via that will go to metal 2 and cross over the metal 1. So we have to go to create via. The shortcut is O. So what I will do is I'll create a via. So I'll select the metal layers. So I need metal 2 to metal 1. Now as you can see, this is a 3-row 1-column RIA. So we can change the number of rows and columns in it like this. So suppose I want it like this. So see here. Now a very good approach in analog layout designs is copying things. So just copy this via and place it here. Even you can also copy connections, MOSFETs, everything you want you can copy. So what has happened is this metal one was still here. Now I have this connection on metal 2. So what I will do is I will again go to path. So I have to select metal 2 since there are two metals there, and I will draw a metal 2. So now this connection is done. So we are on metal 2 and we are done. So what one more thing that I could have done is I could have just deleted this thing, and just to be safe, I don't want to put metals everywhere. I can just keep this via over here and extend this till here. Similarly, this will be kept here and I'll just extend it here. So the thing is, since you only have 4 metals, you don't want metal 1 to be running everywhere. See, the thing is, as soon as you go up in the hierarchy, the resistance of metals go down. So it is better to route longer lines or outer lines with higher metals. Fine. Now we have these two grounds. So as you can see, these two are perfectly aligned, the MOSFETs. See, one trick that I use is, suppose these two MOSFETs are not very perfectly aligned. Suppose I have a little offset in them like this. So a good thing is, start a path, finish it very near to where you want it to be, and then you can adjust the MOSFET according to the path. So this is perfectly aligned now, almost. So even if you keep a very small notch hanging, it will result in a DRC. So just avoid it. Okay. Now, you see, these bodies will all anyways be connected to ground. This is also ground. We can just pull over a ground like this. Easy connection. So body is connected to ground. No problem. How about this V out? Okay, let's see what are the layers. So if I select M1 and click on this visible, this V stands for visible and S stands for selectable. On visible, only metal 1 is visible to me. Now you can see this is metal 1 caged inside metal 1. So I cannot take out metal 1 from here. So what I need to do is, again I have to put a VIA to get V out of here. So again I'll go to VIA. This time I cannot use multiple columns, and so using multiple columns or multiple connections at a place reduces resistances. So as you can easily tell that going from one metal to another will require a connection that will be resistive. So each via will result in a resistance of about 6 ohm or something. So this is like 6 ohm resistances, 6 ohm resistances connected in parallel. So use as much contacts as you can, but make sure you can make it DRC safe. So now this is my metal 2 drawing and I can use it like this. So don't be afraid of running metals over metals unless and until you are sure that it is a very sensitive line or something. So it is not like you cannot run metals over metals, okay? Until unless it is not very sensitive. If it is very sensitive, then you have to be very careful about it. Just people are sometimes very scared of running metals over metals. So like this is a poly, I can run metal over it, no problem. Similarly, this cap, for the same reason that we splitted the MOSFET, I don't want this cap to be such a long capacitance. What I can do is I can just split it into 4 parts. It is better to keep multipliers in even numbers. It helps in maintaining the symmetry. So suppose I keep only 4 number of multipliers and I'll click OK. So this is one out of the 4 multipliers. I have to create or instantiate the other 3 from my schematic. So I'll just click no, not this. Here I'll go to schematic, select the capacitor. Okay, I'll just delete this. I'll just select the capacitor. Okay, maybe because the schematic properties was not updated. Okay, so I'll just update it here. 100, 400, 100, 4. Perfect. So now I'll just create the capacitor, generate from source, and that's it. So now these are 4 pieces. I can just arrange them like this. So arranging them is crucial, like you need to maintain symmetry. Okay, so if you want to measure things, you can use scale that comes from K. So I don't know whether there's I don't know from where we can get this, but okay, here it is, create measurements. So when you go to create measurements, you can create scales to measure. Suppose you are very much stuck in very minimum area and want to clear DRC rules or want to accommodate something, you can actually measure things very neatly, and then so this will be like very accurate, and then you can place them. So one use of this is to maintain symmetry and other things, like you can measure the distance between these. It is not very symmetric, it has some changes. Similarly, you can arrange things symmetrically. So once you are done with this, suppose we have created all the connections. I cannot do it because of crunch of time. So after I'm done with all the connections, only thing I'm left is the pins. So these pins were created when I generated everything from source. Suppose this is Vn. So this was created in some metal that was selected during the generation, but your pin need not to be in this metal. So what you can do is, suppose I want VDD and ground on the top metal. So VDD and ground has to be very low resistance. Suppose I keep it in M top I'm drawing. Okay, so these are my pins. So what I will do is I'll go to P path and then I'll create a top M drawing. So this is my metal. So keeping the VDD and ground runners like this is not a very good idea. You have to keep it real thick, 5 microns, and these can run over anything. Like these are not very resistive, and these are at the top level. So if we can keep it on metals, even on the top of this, because there is no connection, it's up to you. Just you have to think of things in 3D. So these are my 2 runners. What I plan to do is I'll just give this pin a decent size. So I'll go to properties. So I'll just keep it at 1 1. Now I'll move things around and keep it at the VDD. So as soon as I have, as you can see, till now this metal has no net. As soon as I keep this pin on it, it will get a net connected to VDD. Done. So this is my VDD. Similarly, I can create my ground. And done. So my ground and VDD are created. Similarly, I will be keeping V in somewhere. If this is V out, so let us suppose we keep V out. So to move, you can use M. M is used to move things around. So this V out is suppose somewhere here, and these when we will be